Okay, here we are at exercise 6 in Learn C the Hard Way, and we're doing more memorization. Exercise 5 was a smaller memorization task to get you sort of into it. You should be able to do that pretty easily if you've done 2 other programming languages because a lot of the operators are the same. In this exercise, you're going to memorize the keywords of C and the major syntax forms. Now again, if you've done 2 other programming languages or even 1 other programming language, these are going to be very similar, but it's mostly just memorizing to how the forms are and what the keywords are, so that way it makes it easier for you to read C code later. Trust me on this. Memorization is your fastest way to get through learning this language, and it's not that hard. It just takes effort. That's all it takes. Something that we sort of have lost in education is just the effort of learning basic skills, and memorization is one of the basic skills. It's not painful. You can turn it into a game and make it fun, and it's really useful later on when you want to teach yourself many things. So, let's look at what you're memorizing. This exercise is larger. I'm going to admit that it's just larger. But it's something you can do. If you have the time and you have the effort, it's not hard to go through a lot of these. Many of the keywords that you're memorizing are similar or exist in other languages. And also, you're memorizing code forms. So we're going to go through those really quick in this presentation and then read exercise 6 in the book. Now, I'm classifying these in generic terms, execution keywords. C might call them something different, but I'm sort of getting you into the concept that this is a trick to learn any programming language. Here we have them. Most of these you know. The only one you might not know is switch. If you come from a language like, say, Python, it doesn't have them. And case is part of switch. So that's it. Goto. A lot of languages have taken goto out, mostly for reasons of safety, but sometimes it's useful. C has it, it's useful. We actually will use it in the book, so that's going to be fun. Now we have types. C is a typed language, but it's not typed in the way modern languages are. Modern languages are much more explicit about what type means. C is more like it's typed, but yeah, it's not very strict about it. One of its problems, actually. Most of these, you should be able to figure out what they are. The only 3 you might not know is void. So void is just saying, yeah, this doesn't have a type, or it's undeclared, or it's empty, okay? The next one is union. We'll get into what that is. Union is sort of a useful data structure for reusing memory in different ways is one way it's used. Another way is to sort of compress memory, so you can have the same data structure be used for multiple things, but take up less memory, and so on. And then struct, if you come from an object-oriented programming language, struct is usually, I don't know, best described as like objects without functions in them. That's sort of a lame way to describe it, but that's the best way to describe it. C is not an object-oriented programming language, but you can bolt it on if you want. Data keywords, for lack of a better word, is sort of how you describe how to store or manage or access the data types that are back here. So you have types like char, and then you can come in and say this particular variable is a constant char, or this particular variable has auto or register classification. You can also say it's signed or unsigned. And you can use size of to get the size of things. So that's another keyword. It's not really, it's not really something you tack onto data, but it's something you use to access data. You can declare things with a type def to make your own data types. So that's a very useful way to save yourself some typing, and to also sort of like make new types that are supposed to be similar to each other. So that's pretty much all the keywords. C doesn't have a lot of keywords. It's got these, those, and those. I would spend a lot of time memorizing those, and then set up a second batch of cards for the if statements. So what you would do on in your index cards is put this on one side and then this on the other. And if you want, type them out. It might even be easier. So if statements. If you come from JavaScript, you already know this. This is pretty much how JavaScript, Java, any other language, they inherit from C's format. If you come from Ruby or Python, this is going to look unfamiliar. So study that. You should be able to figure it out, though. You know, about the only thing is, say, in some languages, they combine the else and the if into one word, like elif or else if. Switch statements are found in Ruby, but maybe not Python, or necessarily not Python and some other languages. But all a switch statement in C is a way to make an efficient if that jumps around based on integers. So we'll get into how that works later, but you definitely want to remember the case needs to have a break, and then that you have to have the default. Those are the two key things to remember. So memorize that. Oh, and you should also notice when I put something in caps like that, I basically mean it's sort of like a placeholder. So code goes here, a constant goes here, an operand goes here, and so on. While loops. You should be very familiar with while loops. One thing that trips people up who come from languages like, say, Python, is they read, okay, while, I know what that is. Okay, parentheses, wait, is this a function? And their brain sort of freaks out because in Python, you don't have these parentheses necessarily. So you just have to get used to it. In C mode, I put a parentheses there. And then you have these braces. And in other languages that don't have them, your brain hits this brace and goes and freaks out. And is like, what is that? It's jarring. It's unfamiliar. Memorizing these will help you read this and go, oh, it's just a while loop. That's all it is. I'll throw in this while with continue. So that way you sort of like have a larger set of things that you're familiar with. So when you see continue inside a while loop, it continues back to the top and keeps going. Same with while with break. It's just a while loop, but then if you have a break, it jumps out of the while loop. Do while. So this is found in many languages and not in others. So you do this code and then do the test to see if it should loop back to the top. Also a really common idiom that's actually fairly useful. For loops you should be familiar with. If you do JavaScript, this is very familiar. If you do Python, maybe not so much. So the main thing is in C, you have to set up your own counters to go through things. C's for loop is not an iterator through structures like it is in languages like Python and Ruby. C's for loop is an iterator through integers and counting. So it's more like JavaScript's for loops. So the idea is instead of saying go for each element in these structures, let me do some code. This is easier with code than talking. So in Python, I would do for, if I had say like x equals 1, 2, 3, and I would do for j and x print j. Okay, pretty straightforward. So I'm just going through for each element j and x print j. Now in C, I don't necessarily have the same thing. In C, I'd have to create an integer, I, and I have to do for I equals 0, I is less than the length of j, or of x, so 3, and I plus plus. I have to make my own counter to go through it. And then I can do printf %d x I. Like that. I have to explicitly make my own counter. So that's what a for loop is for in C. Enums are very useful. Instead of going around and making a bunch of constants and using them that way, you can bunch the constants up into an enum, and then you can say things have that type, but the enum is also interchangeable with integers. So we'll get into that later, but just memorize this constant, or this enum form. Okay, so goto. Goto is a really common thing to use, but it's also very error prone. So you have to use it sparingly or hide it behind macros that make it less error prone. So we'll do that when we get to the exercise in Zed's awesome debugging macros. That's what we'll actually be doing, is we'll hide goto behind some macros so that way it's way easier to deal with and less error prone. All right, functions. In C, you have functions, but you have to declare their type, and you have to also make sure you have a return value, and you also have the same arguments. But other than that, and you got the bracing, but other than that, it's pretty much the same. Now we have type def. So type def is basically a way of saying this more complicated type is going to have a new name. That's all it is. And we use that later when we make structs to make it a little easier to work with structs. So for example, I could do that. I could say type def unsigned character byte. All right, so now what we have is structs, struct name elements, Basically, you can tack on that variable name part. This here is optional, and it's a way you basically make, like I said, kind of like an object where you have different elements and you can access them individually. So we'll get into that later. Also, keep in mind, I'm not fully explaining what all these are. I'm giving you a light tour so you have something to grab onto when you do your memorization. I'm just giving you enough to get your memorization done. We will learn how to apply these later on in later exercises. So remember, it's a magic trick. You're going to memorize and you're going to see when you get to later exercises, you're going to go through it and be like, oh, I sort of already know what this is. And it's going to be easier to work with. Now, the other thing you can do is you can go type def struct and then just tack on the identifier, so that way you don't have to say struct name everywhere. This is a common idiom. Some people who code C hate this idiom, so keep that in mind. Unions. We'll get into what unions are, but the main thing about a union is it's like a struct where all of the elements are sort of like stacked on top of each other in memory. So that way the union only takes up as much memory as whatever happens to be the largest. Unions are more commonly used to take an opaque piece of data and then pile on structure inside of it so you can access different parts of it inside the RAM in different forms. That makes no sense, but just trust me. Unions are useful, but you won't run into them super often. That's everything. So remember, make some cards and drill these. Drill these as much as you can, but you don't have to stop here. You could be doing exercise 5. You have cards for exercise 5, cards for exercise 6, and move on to exercise 7 and just be drilling these during the day. Or you can just spend a week just memorizing these things. Memorization will help you. Please trust me on this. Just fight the urge to have your brain tell you this sucks, this sucks, this sucks. Just fight through it. It's such a good hack. It's such a quick way to learn things, and it's such a useful skill. Hopefully, when you come out of this from this book, just learning how to learn a programming language by memorizing the keywords, structure, syntax, and operators first will be the best thing you get out of it. All right, thank you. See you at the next lecture.